The other problem that I wanted you to have a look at on your study guide was problems 10 through 12 on page 6. And in this problem, we're told that we have two guys put a crate on a ramp that makes an angle of 30 degrees to the ground, and the crate of mass 200 kilograms doesn't slide down, but it's held there in place by the force of friction. And so we're curious as to what is the coefficient of static friction. The first question asks us to draw a free body diagram, and so we identify all the forces and draw them in the directions they need to be headed. So force of gravity, Fg equals mg, Fg equals mg, Fg equals mg. Keep your mantra going up as your force of gravity goes down. There's force normal, which is perpendicular to the contact surface. Force normal is always perpendicular to the contact surface. We have a friction force that is opposing motion. We have a friction force which is opposing motion. So when we first draw our free body diagram, this is what it looks like with just three forces: force of gravity, force normal, and the force of friction. And you say, well, what about the force that's opposing the friction force here? Well, it's there. It's one of the components of the force of gravity. And number 11 wants us to draw that now. Number 11 says draw a second diagram showing the components of all the forces acting on the crate in a coordinate system that makes it easy to apply the law of friction. Okay, so now we're going to redraw this. We got force normal going off in that direction. We got force of friction going off in this direction. Now, instead of drawing my force of gravity in one vector pointing straight down, I am going to draw it as having two components. This way and this way. So that this is the force of gravity that is perpendicular to the contact surface, and this is the force of gravity which is parallel to the contact surface. This is the force of friction. This is force normal off in this direction. Now, this is the forces drawn on a coordinate system that allows us to use the formula for the force of friction, which is force of friction is equal to coefficient of static friction in this case times the force normal. Okay, this is what we're after. We are trying to solve for coefficient of static friction. If you rearrange this equation, then it is the friction force divided by force normal. And now we see that the friction force is equal to the force of gravity in the perpendicular direction, and that the force normal is equal to the force of gravity in the perpendicular direction. So it's just a ratio of these two forces. Now, how did I know that they were the same? How did I know that? Well, the sum of the forces is 0. The sum of the forces in the perpendicular direction are 0 because the crate is not the crate is not bouncing up and down on it's not accelerating up and down on the ramp, so the net force in the perpendicular direction has to be 0, and the crate is not sliding or accelerating down the ramp, so the sum of force, there is no net force, so the sum of forces in the parallel direction have to also be 0. So when that happens, I know that this is equal to this and this is equal to this. And so now I think we can just plug some numbers in. No, we're actually going to have to try to figure out what these forces are in terms of this angle of 30 degrees. And this is exactly like the one problem that we did on the board today. So let's see, I am going to have to draw such that the angle of the ramp is here. This is theta, so this is 90 minus theta. And this one is going to be theta also. And now I can see that I have a triangle here, and I have a triangle here. And so let's go FG parallel is this vector here. That would be the opposite. So I think this is going to come out exactly how the one in class did today. FG sine theta divided by FG cosine theta. And now you can simplify this just to be tan theta is going to be the coefficient of static friction. Of course, you knew that. You've done these problems already. You know that the coefficient of static friction is just going to be the tangent of that angle. I'm going to have to figure out another way to ask this question so that you don't automatically go to that answer without showing any of your work.